Hello. My name is Justin Cormack. I'm sadly going to be speaking to you in English today, but maybe it makes a change. I work in the security team at Docker, and I'm going to be talking to you about security for working with containers. I'm based in the Cambridge Docker office, Cambridge, UK, so it's very easy to get here to Paris. We also have an office here in Paris. If you'd like to come and work with us, we're hiring in Paris. The head office is in San Francisco, but Docker's started in France, so we've always had a lot of attachment to France. What have containers got to do with security anyway? Why does it matter if you're using containers or not? What's the kind of difference? And I think the important thing about containers is that you have a concept like you do when you're manufacturing things of a supply chain, and you can kind of think about it in the same way as a physical supply chain where you're making products and you want to understand when you ship your products, you know, if someone has a problem with your physical product, how can you tell when it was made, how it was made, what exactly went wrong with the construction process because there was a fault, and you want to be able to make sure that everything you ship in your physical supply chain is exactly the same each time, and you know which pieces it was built from and where there were changes. You can understand if there were problems with the components you used, and you want this to be easy and cheap to do. And I think the same is very much true with containers. The same way as you have little printers that print identifying information on products like eggs, so you can see exactly when they were packaged and where the source of them was. You have the same long, confusing hashes. That's the latest Nginx image when it was the other day. So you have the same identifiability. You can see when you're running it in production, this was exactly the version you used, and you can understand if you find a problem with it, you can pull it and test it locally and with exactly the same version. Containers are also tamper-proof in the same way that you have these special tamper-proof seals that if someone modifies a container, it no longer matches the hash, and you won't be able to run it anymore. And containers are great. You can reproduce them, make as many of them as you like, exactly the same, which is really, really helpful if you want to scale out in production and know that every node on your cluster is running exactly the same version. And containers are really, really useful for this. Before you had containers, it was difficult to do this with software, not totally impossible. But containers really make this a very easy process. You can use exactly the same container for local testing, for your CI testing, and in production, you don't rebuild your container each time. You just use exactly the same one and just push it to different registries. Containers are identified by the content hash, so the exact contents of the container. And if you have a problem in production, you can run exactly the same container locally and test to see if you can reproduce the problem locally. You don't have to try and go back and check out the old version of the code and rebuild it or anything like that. You can just pull the same container, run the tests against it, and see if you can reproduce a problem that your customer's having or that you're seeing in production locally. And this is all really easy. So this is really helpful, and I think it really makes it kind of useful to think in this sort of supply chain. I mean, this is a slide we sometimes use showing the idea that you have a secure platform and authorization, and everyone can work with containers like that. However, that's why it's really important that you understand that security is not a tooling issue. Security is a process for making better software. And there's no real difference between security and other kinds of bugs. It's just software that's secure is software that doesn't have bugs in. Security bugs are just a particular class of bugs that you have that cause particularly bad problems. But it's just about making quality software. And it's a process of working with your team to make better software. And it's just like working with your team to make sure your software is reliable and does what it's supposed to do as well. And it's an effort for your whole team. You can't have one person just doing security. You have to have everyone thinking about security. People have different amount of understanding about different parts of your applications because applications are complicated. Some people understand more about details of networking, and some people understand more about how the authorization in your application works, and everyone has to work together to understand how this affects the security of the whole application. And you can't just do this once. It's no good the day before you're going to ship just asking someone to do a security audit, because that means they won't be able to do it very well. It's really time consuming to do it well. And it means that you have to stop before you ship and do this audit process rather than actually thinking about it and planning it and testing it ahead of time and doing it all the time so you can do continuous delivery. So you want your code to always be secure at all stages of development, and not just security be some sort of thing you do as an afterthought. The best way of doing this, I think, and that's what we do at Docker in particular, is that we embed people from the security team into application teams so that there's someone who's assigned to your application who understands the security issues with it, the risks, and how the structure of the application is, how it works, so that they can help developers out if they have security-related questions. They can help design parts of it that are security sensitive, like authentication. They can point out issues that you might not have thought about because they think about these things more often. But they know the application because they come to your meetings and they understand the structure of it and what it's trying to do and what information it's processing and which bits are exposed to the internet and so on. And so that if there's a problem later on, you don't have to bring them up to speed and explain everything. They'll already be someone who actually can understand what might have gone wrong and help work with you and help fix problems in production. It's really hard to bring someone along later when there's a terrible critical bug and you try to explain to them the whole structure of your application at that time. It's best to understand it up front. Not everyone has a security team that they can use like this, but it's a good aim to have for longer term as your company grows and think of that model. You don't need one security person for each application necessarily. I mean, we the security team at Docker, each of us covers several different applications. I was saying before, security really is just an aspect of quality. Normally, when you're testing things, you test. Often people are kind of a little bit lazy and they test things as they should happen. You go through with a shopping cart in the application and you buy the product and make sure that you can check it out. That's great. But security means testing things when they go wrong. What if someone, changes the form submission and changes the price of the item they're buying so they can buy it more cheaply? Or, those kinds of things that are not supposed to happen. The interface doesn't let you do that, but someone might try and do it. So you need to test things that go wrong, things that are people are actively trying to make go wrong, because just testing things that things work is just a starting point. You'd also need to test how things fail, how things don't work. So it's an aspect of quality. It's no different from other aspects of quality. It's work that you have to do to make a quality application. Pursuing quality is time-consuming and hard work, but it's also very satisfying because you're making a great product, a product that's you're happy shipping, and it'll be less work when things go wrong later. Here are some kind of tips for developers using containers. Really, a lot of these things are quite straightforward things, but we spent a lot of time at Docker working on official images for as many applications as possible. They incorporate the best practices about running a particular application and for building applications and so on. They're constantly updated, so someone is there looking for security issues and making sure that they get the updates out as quickly as possible. They're well tested, lots of people use them, so you're less likely to run into problems. They're pretty minimal, they only contain what you need. They're based on modern operating systems, so they don't have old code that's never been fixed. If you're using Linux, the Alpine and Debian Stretch ones are the most recent ones that we're currently shipping, and they're probably the best ones to use. Some images have a wider variety of base images, but it's always best to use the recent ones because they will get all the updates, and the old ones may actually have be updated less often or not at all. If you're using Windows, you've probably got less choice because there's just Nano Server or the Windows Server ones. If there isn't an official image for the application you're using, then try and talk to the upstream project and make one. We do add more official images, and the guidelines for making an official image are just really helpful if you're building an image yourself. They list all the things that are required for an official image, and it's worth reading those anyway. They're really quite helpful guidelines about making base images. One of the things we try to do with when we build Docker was try and make all the defaults safe for security, reasonably safe security defaults. So if you just run things as they are, things should be secure, the platform should be secure, and it should be suitable for pretty much every application. There are always exceptions, but I spent quite a lot of time working on things like the default seccomp policies, and people would say, oh, it doesn't work with 32-bit Oracle, and so I'd fix the issue with that because it should work with 32-bit Oracle, and we haven't had any people complaining about things for a long time now with those types of things. So there's built-in security policies that are there, and it's best not to try and change them if you don't have to. There are some things that we haven't been able to make the default yet. In particular, user namespaces are running as non-root user. Containers by default run as root, which is not as bad as running something as root on a host system, but it's not because it's actually a somewhat restricted root. There's things you can't do even as root, but it's not ideal. We'd like to fix this in future, but there are some issues with applications that don't work yet. So just running your containers as a different user is a really good idea as an improvement on that. Another improvement you can do is to use read-only images when you run them, which means that nothing in the image outside the volumes can actually change. So you know that over time nothing's being modified in your image, that if someone somehow attacks your service, they can't modify the application inside it. You can set this with in Kubernetes as well in the security context. If sometimes official images don't work read-only, which is really annoying, so please file a bug. I found a couple that didn't. And then so we set up these defaults that work. Don't make them weaker. Don't use the minus privileged option. Don't use cap add sysadmin. Don't use sudo inside when you're running containers, because that suggests that you need to run privileged things inside your container, which you shouldn't really do. You should just be running an application. You shouldn't use the Docker socket inside a container because that gives you access to everything on the host. Very occasionally you need to do these things for debugging or for some really privileged application, but be really careful if you're doing these things and don't just kind of routinely do it. And secrets. Lots of applications need secrets for connecting, a password for connecting to a database or things like that. You have to repeat this always. Don't check your secrets into Git because you'll someone will get your access to your code and find your secrets. Someone will accidentally push them to a public repo, or you might open source your code and it's got all your secrets in it. It's really not a very good idea. Docker and Kubernetes now have really straightforward to use secrets APIs, which are there to use them. There are also external tools like Vault and cloud provider tools for managing secrets that you can use. Often you'll still need a secret to connect to those in the first place. So you can still use Docker secrets to kind of bootstrap those kinds of things. The secrets, the APIs are pretty easy to use and straightforward and much more secure than using environment variables. And so those were some basic tips for developers. We'll come to some more later on. Here's some that dev and ops do together. It's really important to always keep updating your code, because there are old libraries you're using, there are old base image vulnerabilities. Everything, just keeping stuff up to date is really important. As I said, the standard official base images get updated every few days with things that might be security issues. You're using other libraries and they will have updates. It's really hard to tell if something's a critical security update or just a minor security update, and it's best to keep things updated. There are lots of cases of sites that got hacked just because they were using old versions of Apache struts that hadn't updated for 2 years. The longer you leave it to update the dependencies you use, the harder it is, because the API will have changed a lot in 2 years, and you have to rewrite a lot of code, and it's really tedious, so you'll put it off for even longer. Whereas if you do updates constantly on an ongoing basis and use the latest version of each library, there'll just be a couple of lines to change. There'll just be, they'll change the name of a function or add an extra parameter. It'll be something you can just do as you're updating something else, and it'll be really simple. But if you leave it off for 2 years, it's just a real pain. It's like, oh, I don't want to update from version 2 to version 3 because it's such a big change. We'll do it next year, and then you'll never do it, and then there'll be a vulnerability, and there won't ever be a new, there won't be a new version anymore, and you'll regret it. So just keep, every day, or every few days, once a week, just look and see if anything's been updated. Just do an update, change the version, check it builds, test it, and small changes are easy to handle. Don't try and keep your containers running forever. This little image here is from back in the day. There used to be a kind of competition with. I used to be a sysadmin. Sysadmins had this competition so you could keep their server running for the longest. I found this one on Twitter a few months ago. Someone who had their server up 6,519 days. That's like 18 years or something. That means you've never updated probably everything on that server for 18 years, and it's probably running some slightly outdated software. It's probably running some software that someone else has installed on it that you didn't know about. With containers, you can just restart them all the time. We have this kind of concept of kind of negative uptime, that the shorter something stays up for, the less likely it is to be hacked. If someone has hacked it, they have to re-hack it again because you've just thrown them out and created a new container. So you can basically, every time you update it, you can ship a new version that has security updates, or you can even just restart it and just make it really annoying for someone who had somehow hacked into it or anything. So don't think that keeping things up for 18 years is a good idea, and you're not going to win a prize. Also, just continuous delivery, just getting out small improvements every day, making your code a little bit better every day is a much simpler and nicer way to work than to do big updates every 6 months and so on. The more often you deliver, the better. I think continuous delivery is a really amazing thing in terms of developing software. Scanning tools are really great. They tell you if there's known problems in your images. This is from one of the standard library scans. There's actually loads of scanning tools. So Docker Enterprise Edition includes a scanning tool. If you don't have any money and you're not paying for anything, CoreOS Claire is totally free and open source. You can just install it yourself. So you've got absolutely no excuse not to do scanning, whether you're using there's loads of paid services as well. All the vendors have services, and they're all pretty. They vary a little bit in terms of how well they cover specific programming languages. Some of them are better for things like Ruby, but mostly they use similar. They're fairly similar. But you've got really no excuse. There's paid or free products, and you can just run. You can run Claire yourself. It just needs you can run it in a container and scan your images yourself. It's really easy. Signing is we've spent a lot of time actually working recently on the Docker trust commands for making signing easier, because it was a little bit painful to understand how the process of image signing actually worked. But it's now getting much easier in the recent versions of Docker. And so you can have processes that do things like only running images when they've been signed, so that you know that someone's actually said that this is ready to go and passed testing. There's workflows you can integrate signing into your CI pipeline so that it's signed once it's passed tests and things like that. And the official images are signed. You can check the signatures on them. We need to make that happen automatically soon, because it's kind of about time for that. If you're an ops, when you're running containers, you don't need to run a big general purpose operating system that's doing all sorts of stuff. Use a small container specific operating system ideally. There was a talk yesterday about Linux Kit, which I worked on, which is a great option. There are other options as well. If you aren't using a minimal OS, make sure you're using an up-to-date OS. Again, don't keep your hosts up forever. There's no real need to. Only run exactly what you need to run containers. So run, Docker or Kubernetes or whatever you're running, and you can run things like monitoring and logging and applications like that in containers or as software as a service or something. So you don't really need to run much on the host itself. Monitor what's going on. I think if you're worried about security, but you don't have any kind of intrusion detection or anything, you'll never know if someone has hacked you. So it's kind of it's a good idea to have some sort of tooling that will help you. There's a lot of companies that do container-specific intrusion and monitoring, but it's definitely worth looking at. Access control. If it's all very well having a secure application, but if someone can log in and run an application that you shouldn't be running, it's just as bad. So you need to control who can actually deploy things to production, and have an audit trail so you know what actually went to production when. Again, Docker EE has a full role-based access control with Active Directory and LDAP integration if that's what you want. There's a practice called GitOps, which is quite new, but that is quite exciting, where everything that goes to production gets put into a Git repo, and then once you merge the commit, that will automatically deploy everything about your infrastructure based on that Git repo. So it might create machines with Terraform, deploy containers with Kubernetes. There's all sorts of kind of parts of GitOps. So you get an access trail from who can merge things into Git, and you get the access control you get the audit trail from actually seeing from the Git history. So you can go back in time and say last Thursday, I can look in what was in the Git repo last Thursday and see exactly what the state of our infrastructure was at the point which someone reported a problem. And so you can go and roll back another copy of it to there, or you can look at the containers versions that we're running and test them and so on. There's a new project that just joined the CNCF sandbox called Open Policy Agent, which is designed around building custom access control policies. That's really nice. It's got some examples for Docker, Kubernetes, and other things. It's a tool that Netflix uses for a lot of their access control for a lot of their hosts. It's quite new, but I think it's really nice design for writing policy for access control. Some more advanced things. One of the things that I think is really important is just, as I said, security is about quality, and quality is about writing better code. And there are lots of ways of writing better code. One of them is code review, which is obviously incredibly important, is someone else looks at your code, not just you, because they'll notice the things that you missed. So it's always good to have someone else comment on all your pull requests, and make sure that the team always has someone, at least one person, review every pull request. One way to do that is just to not let anyone merge their own pull requests. Someone else has to merge them. Or you can have formal reviews. A lot of open source projects do that, but you can do that internally too, and just enforce that you can't merge things without someone reviewing them. Pair programming is another way of doing reviews as you're writing the code rather than afterwards, which often works for people. I think a lot of people like that. If you haven't tried it, just try it one day and see if you like it, how it works for you. Depending on, it might not be something you do all the time, but sometimes you could do it some of the time or all the time. But if you've never tried pair programming, it's something you should try. Code analysis tools are really helpful. They can also be really frustrating as well. If you've never used a code analysis tool on your code base, when you turn it on, it will come up with thousands of issues, and that can be really daunting. The kinds of things that are really useful for code analysis tools to check, it's not the things like a sort of linter does, that the names of your variables or stuff like that. It's things like, have you failed to check an error condition? Have you failed? Are you potentially constructing SQL injection attacks because things are coming from untrusted things? Are the file names coming from untrusted user data and things like that? So there's a lot of things that they can check for. But if you turn them on, they'll give you loads and loads and loads of issues. And the best strategy with that is to basically either to not force zero issues in a CI pipeline on a code review tool, because that's really quite strict, especially when you start. You can turn off some whole classes of issue if you don't have time to deal with them immediately, and then you can go back and you can basically add them one by one over time as you improve the code. But it's still better to run a tool with some of the options turned off than it is to not run it at all. You can add annotations usually to the code saying it's not a problem really, but that's it can be a bit annoying. You can run them in your IDE to check, but then you tend to, if there's thousands of errors, you tend to ignore them because it's too many to deal with. You really need to get them into the stage where you fixed a lot of the issues and change the command line options to be more kind of helpful for your code, and then you can then it's more manageable. There's a lot of options. I've listed a few here. There's a bunch of open source ones. Coverity is the most well-known commercial option, which you can use as an online service as well as installed locally as well. And often you'll find that some of them are integrated into your IDE, but again, it's good to have them in the CI pipeline so that everyone sees the output, and you can do things like show diffs of the output if necessary. So you can see what changed in your PR in terms of the output if you haven't got rid of all the issues. But they're definitely worth looking into and spending some time understanding the kind of issues they're finding and whether they matter or not. Better testing. This is the old joke about test engineer walks into a bar and he orders a beer, orders 0 beers, orders 99999 beers, orders a lizard. You know, you have to try all the weird test cases that appear to be stupid and make sure that the behavior is actually sensible, and that the errors are actually caught. So just think about, I mean, the idea is you need to think about all the weird cases as well as the normal cases. There's the happy path thing I was talking about. You have to look at the sad path. What happens if someone orders -1 items in your shop? Do you pay? You don't want to pay them if that happens. There's a whole lot of fairly new testing and techniques that are becoming much more accessible. These things used to be impossible to do. Now they're still difficult, but not impossible. Fuzz testing is really useful for some types of applications like APIs, where you basically, the idea is you have an automated program that takes a normal input for your API, you know, a JSON document or whatever it might be, and then it just starts to change things. It doesn't just change things at random because most of them would be invalid. It actually looks to see which things, when it changes them, it changes the execution of your code. And so they're kind of quite, they actually kind of can be quite magical. You can actually use them to sort of generate valid cases and things like that. They can actually go and work out from changing things how to generate a valid and invalid document. Property-based testing is another new and quite exciting thing. There's quick check is implemented for a lot of programming languages. I think it started off in Haskell, and it's a sort of similar. You build a sort of model of how your code should work, and it tests your code against the model. And again, it can test lots and lots of cases that you couldn't actually manually write tests for, and give you much better coverage. The other ones are even more difficult, but I think it's worth looking into if you're interested in testing. I thought there's other things. I mean, people like to look at test coverage measurements and make sure that they only, the test coverage. People don't check in new code without coverage changes and things. I find coverage measurements tend to be a bit unhelpful. I don't think they necessarily give you a really good idea of how well things are tested, because a line of code is executed doesn't necessarily mean that it's doing the right thing. But it can be helpful. It can tell you, one thing it does tend to tell you is if you're testing all the error paths in your tests, because a lot of your code, when you're writing code, a lot of your code is to do with handling errors, and if your coverage is low, quite likely it's the parts that handle errors you're not testing. So measuring coverage is it can be helpful, but it can be a bit overrated. For security in particular, I think it helps to think like an attacker. If you've never actually tried hacking something, it's actually it just kind of changes the way you think about doing stuff. So there's a lot of like online hacking challenges and things like that you can take, or you can just look at your code, which you know quite well, and think, if I was an attacker, how would I try and break this? And just try it and see what happens. You might find something that you didn't expect, or you might not. And if you know your code really well, you have an idea about which bits might have some kind of weakness. Usually, you think that if there's something that your code does that you think is a little bit odd, or you think it might not have enough checks, just try and break it. Just feed in invalid values, try and change the URL parameters, feed in different things through the forms, whatever you can do, and just try and hack your own code and see if you can. Another thing to do is just look at the common issues. There's a list, the OWASP top 10, which is the top 10 security issues. It covers, the top 10 is things like cross-site scripting, SQL injection, things like that. The top 10 list rarely changes much from year to year, and it covers the vast majority of security issues that you see in practice. So you can just look through that list and see, is this applicable to my application? What's the best practice for dealing with these things? There's lots of helpful stuff online about things like how to stop cross-site scripting. It's a kind of fairly well understood thing. There's a checklist of things you can do. Just go through them all and try that. You can also, again, you can see if there's a few common places where there are cross-site scripting and code injection issues. Often error pages do things like print form parameters, and if you add parameters, you can get them printed on the page, which means you can often run, if they're not properly sanitized, you can actually run JavaScript on a page and things like that. So there's you can play around with the actual application and see if you can do those things once you get the hang of it. Just look at your code as an attacker and get used to that kind of mindset. It's quite fun, actually. And you don't have to do it all the time. But you can maybe set aside an hour a week where you or a little time in one Monday morning. I used to go and try and find a security issue in the application I used to work on. And sometimes I wouldn't find anything, and sometimes I'd find something. And sometimes it was a big thing, sometimes a little thing. But if you do that regularly, then your code will get better all the time, and you'll also understand your code better as well. It helps you learn how things work in a lot of detail, which is really helpful. Work together as a team. The security needs to be a team effort, something that you need to work with your team members on, talk to them about things you think might be problems, work out how you're going to change the tests, work out what you're going to do together, and work out how you're going to make better applications together, because that's the aim of it, is to work, is to make really, really good applications and really improve them, keep improving them, and make them secure, so you don't have to worry about security issues later on. And having that build pipeline, having a good understanding of how your application works, understanding the immutability properties of containers, and then you having this whole kind of sort of whole view of things from development all the way into production as a secure supply pipeline and supply chain is really helpful, I think. And so definitely using containers makes a lot of this stuff much easier than it used to be in before containers, and the tooling is really there's loads of really helpful tooling around containers, but in the end it's not really the tooling that's going to make it better. It's the time that you spend working with your team and actually making things better. So thanks very much. We've got some time for questions. Yep. Yeah, it's a bit more. No, I think we need to do some work on making it slightly easier. Generally, the easiest thing to do. The easiest thing to do is always to. Or normally it's checking out code. So normally the easiest thing to do is to check out the code before you do the build. So if you're using most of the kind of CI systems will have some way to inject secrets into the actual CI system itself, and then you can use that to check out all the code from your Git repo. So you give it you give it an account on GitHub if you're using GitHub or whatever, and then it can check things out. And then once it's checked out, the build doesn't normally need any secrets. If you need to actually pass secrets into the build, you can use the build args in Docker, which are not transferred into the container, so that you know that those won't be written into the container. And then you can do Docker build minus build args, and those get passed into the Docker file. They look a bit like environment variables, but they're not persisted into the container. You can also do if necessary, you can do multi-stage builds. Multi-stage builds can completely start again from scratch, so you can wipe out any history that had secrets in. So you can do your multi-stage build where you do from one base image, build everything with secrets, and maybe even in environment variables if necessary, or build args, and then you do another from line for runtime, and then you copy just the outputs into that. Multi-stage builds are really good anyway because it means your images get much smaller. You don't need all the stuff you needed to build your application, which is usually the stuff you need to build your application is often 10 times as big as the stuff you need to run it anyway. So if you haven't started using multi-stage builds, they've been in Docker now for about a year. Most people have got an up-to-date version that's got support for them now. All the CI platforms have, and they just make the whole process much nicer because you just end up with a build time image which is big, and then a runtime image which is much smaller. And that you can be, if you're careful, you can make sure that all the environment variables and secrets and anything that might have been in the build process have been wiped out as well. Yeah. Yeah. Okay, so the question is, if you've got sensitive data coming into your container, say over TLS, and then you need to write it into the file system in order to give it to another process. So it depends a little bit on your situation and exactly what the easy solution for encryption at rest is to use encrypted volumes. So you use a volume driver that supports encryption. That's not necessarily good enough, but it can be. So that way, the data on disk will be encrypted, but you can still potentially, because it's mounted unencrypted for the container, you can still see it. So that's not necessarily good enough. Yeah, so those will be able to see it. So you really need to encrypt actually get the process to encrypt the stuff with a key that the process is going to read the file also has. You can either use symmetric or asymmetric encryption for that. So why is it not possible? Okay, if you don't have the source code and you want it for the shortest period of time, and it won't take input from a pipe, so you can't decrypt it and input it into a pipe, then, and it has to be on the file system, then the best solution would be to use a temp-fs mount, because that's not going to be persisted on disk anywhere, and just share that between those two containers and make it a private mount, and that's probably the best you can do. But we can talk about it afterwards. There's a few other options. Yeah, I mean, if you've got the source code to the program, then you can, or it takes input from pipes, then you can encrypt stuff and decrypt it just as it feeds into the pipeline. But if it needs it actually on disk and you can't modify the program yet, so you're in a slightly more difficult situation. Any more questions?